sorry there. It's okay.
Okay. The Hangout is live on air. Yeah. Hello world. So we're going to have a look into Fusion 360 with Mr. Paul Sohi. Joining us in Aalto Fablab. If I show you around, we've got. Oh, yeah. Wave everybody. You're live on the internet. All right. Okay. I'll hand you over to Paul.
Cool. All right. Hello, everyone. Hello, everyone. I'm going to stand up. You're not going to be able to see me on this one. Sorry. Actually, I just realized, can I HDMI from that?
If you share your screen there, then.
Oh, yeah, duh. So, cool. Okay. Can you full screen it there?
Yep.
All right. Cool. Hello. So I am Paul Sohi. I work for Autodesk. I am the Fusion 360 specialist for EMEA, so that's Europe, the Middle East, and Africa. And basically my role is I spend half of my time working on special projects. So for the last 10 months, I've been working with Denise Schindler, who is a Paralympic cyclist, and I've been making the world's first 3D printed performance prosthetic. So she's going to be the first person at the Paralympics ever to use a 3D printed prosthetic. She's also the first person ever to receive one made this way for a performance sport rather than just an arm, so it's a lower limb one. I'll talk about that a little bit more later. The other half of what I do is I work with startups, makers, and anyone who's doing something cool, and basically support them. So that's everything from tech support, helping them learn the software, through to product consultation and actually being part of that design team. Everything that I do is free. It's something cool that we're doing at Autodesk right now. So I specialize in Fusion 360. So if you're using Fusion and you need help or you want to develop your product, then basically just give me a shout and I will come and help you either remotely or in person. And I've had this on screen for a little while now, so I might have to explain this to you. So the picture was taken at the Prosthetic Engineer Workshop. We just thought it was really fun. There's about 20 of these. But I can do that basically is something that is based, essentially that's my motto. So I started using Fusion about 3 years ago, and I joined Autodesk a year ago. And I switched from Rhino to Fusion, and when I made that switch, I basically got access to all these collaboration tools, and finally going from working in like a local computer to working on the cloud, and realized that I'm not limited to my skill set. So I studied architecture, and then I shifted into product design, and I was doing sort of traditional product design, and then when I started working with Fusion, I started collaborating a huge amount more because it just made life so much easier. And then suddenly I was doing all these really fun projects like live and interactive installation work. I worked on some music videos. I collaborated with a bunch of 3D print companies. So for a while I was sponsored by Formlabs and Ultimaker, and worked with them on just kind of like pushing the machines to do the kind of craziest things possible. So I try to extend that mentality to the people that I work with to help them make the coolest stuff ever. So I should probably explain a little bit of what Fusion 360 actually is. So Fusion is the newest software from Autodesk. It's designed with makers and startups in mind, so it's software that you can grow with. So it's really, really easy to pick it up, but it also has a huge amount of room to expand and grow and learn with. It's used in industry from everything in fashion accessories, car design, medical industry, interior products. Like it covers a huge gamut of stuff, and it's capable of doing all of that. So the kind of big stuff that you can do, so obviously you can design. This is a tutorial that I sometimes run. I like to show this one because it's a relatively, whoops, whoa, what are you doing? There we go. It's a relatively complex geometry. But you can make this, the quickest anyone has ever done it with me is 45 minutes, and the slowest anyone has ever done it is an hour and a half. I can do it in 5, but I have done it 100 times now. So, but it is really easy to do. And then, of course, rendering is a big deal for everybody. So rendering is built into Fusion. It's cloud-based, so you don't have to have a super powerful computer, or you can do it locally as well. This was a render I did. I wanted to see what it would look like made out of solid wood. And I got it back in 5 minutes, so I just set it up. It took me 10 minutes to set it up, send it to the cloud. I got a little notification when it was ready, and I just downloaded the image. And again, that's completely free to startups. There's no limit on the number of things you can cloud render. And obviously manufacturing. So the Fab Lab here is using Fusion for the CNC machines, and we're testing it out for the laser cutter as well. It's software designed with building in mind, so things that sit inside the computer is all well and good, but everyone wants to see their thing in the real world. So we've tried to make that as easy as possible. You can go obviously 3D print straight out of Fusion, and we have Print Studio, which is our kind of like side product for setting up a slice, basically a slicer. We have partnerships with people like Protomold, so if you're doing like mass production and you want to do injection molding, you can also get ready for that and understand where the limits are on your product. CNCing is really powerful. It's built into Fusion. It's super easy to do, super easy to set up, and it works with pretty much every major machine out there, and even some smaller ones too. And if it doesn't work with your machine, then it's really easy to set it up as well. Yeah. So we should talk about makers and startups, because I keep talking about makers and startups. So makers and startups are the future, and basically what I mean by that is you're not seeing the great innovations coming as frequently from big companies anymore. Smaller companies are taking bigger risks. The students who have graduated and they're going straight into making their own startups, and they're developing products, and they're working on hardware. So crowdfunding has made this really easy. Collaboration is a really big part of that. So teams of 5 are also collaborating with other teams of 5, and you're not limited to your office or the space that you're in, but you suddenly are working with people all over the world. So just to show you a couple of those, this one is Formbox. This is a company called Meiku, and they basically are taking factory tools and making little desktop versions of them for makers. So the first one they did was an injection molder. This was on Kickstarter. It finished on Friday, and they used Fusion to make the whole thing, and they were able to simulate a bunch of stuff. There's thermal simulation built into Fusion, so they could also test how it was going to melt the plastic, which is pretty cool. And they finished on Kickstarter at $560,000, so they did pretty well. This is one that I worked on. This is a company called Stucky. They're an art house that is a combination of jewelry and music. And we modeled and designed a new range of jewelry together. We 3D printed the master molds, and we were one of the first people to go from 3D printing directly to castable metals. So this is about 4 years ago. And that's rose gold, gold, and white gold. You can buy them online if you have enough money. And then this is one of my favorite ones. This is Fabulous Beasts, and that's Tim. And Fabulous Beasts is sort of like Pokemon meets Jenga. So you're playing in this digital physical world where you have a tower that you're building, and you're competing with the person that you're playing with, but you also don't want the tower to collapse. And then there's an iPad that's showing you, or whatever tablet computer you've got, that's showing you the empire as it's being built. And then you can sort of crossbreed the animals. So you can make a spear, which is a shark and a bear, or like a toucan and an octopus, a toucoctopus, I think. It's really cool, super fun game. So all of this is basically what we call the future of making things. So you sat in a Fab Lab, and this essentially is the future of making things. Like, people aren't designing all the way to the end and then producing a prototype and then realizing that they made a mistake and going back and making changes. But everything's happening a lot faster now. You have an idea, you have a concept, and within a week you already built your first hardware prototype, and you're learning from that and you're moving on. And big companies are doing that too, or they sort of slowly are. So down there is like the old way of things. So you have a concept, you start the design, you go to the factory and you start producing it, you sell it, and then you operate and retire, which basically is the way that things happen right now. So the product has a life cycle, it becomes obsolete, a new version of it comes out, and then people buy that new version. The problem with this is that basically you paint yourself into a corner and you paint your customers into a corner. So you're kind of locked into this system. And it also means that if your product sucks out of the gate, it's always going to suck. So my favorite example is like the Nintendo Virtual Boy. Most people don't even remember this thing. It was like one of the first VR things in the 90s. It gave people migraines. It didn't work, and it was a complete failure. Up top is like the new way of doing things. So everyone wants personalized and configurable stuff. So the smartphone in your pocket is probably the easiest and oldest example of this. So you can update the wallpaper, you can play around with the apps. You have apps that are tailored to you, and you can play around with that as well. If you have an Android, you have even more kind of functionality. And that's sort of starting to inform the way that we work. So everyone's collaborating, meaning that if you have an idea, you're not stuck with that idea anymore. You can find people to work with, and you don't have to be in an office in the same space, but you're all working all over the world. The way that you're building is flexible, so CNC milling and 3D printing are becoming really big parts of everyday manufacturing. We're not just relying on circuit boards and injection molding. And the cool thing about that is that you're now getting these little factories all over the world where for a week they'll be building one product, and then the next week they're doing something completely different, versus the old way of doing it, which is you do one thing and you do that thing for 5 years, and then if you want to set up to do another thing, it takes you like 6 to 10 weeks to set up for that. And the customer experience is becoming part of the product. Like Kickstarter is a great example of that, where the community is communicating with the people who are building the thing and saying, we like this, we don't like this, and then they build the next version based on the experiences that people were telling them. But we're taking that one step further by Internet of Things, right? So again, phone is a great example of this. You like something about the user interface, you don't like something about the user interface, it gets updated. And so people are slowly starting to expect their products to get better over time rather than worse over time. So games consoles, again, another great example of this. Sony and Microsoft have been really great with this. Every time an update comes out, the thing launches quicker, it does updates while it's in sleep mode. They add functionality, they take into consideration things like people with handicaps, whether they're colorblind or they can't use the controller. All that stuff is basically what makes the future of making things. The only issue with this is that this might be a little abstract for you. So I'm going to take you through a project that I've done, and then we're going to jump into Fusion. I'm not going to talk for too long. So this is Denise. This is who I was talking about earlier on. Denise won the silver medal at the London Olympics. She's a cyclist. She's missing her lower right leg. So she's got amputated below the knee here. And I've been working with her for 10 months on a research project, building this new prosthetic and figuring out really if we could do something a bit better. So the reason that we did it is that the prosthetics industry is primarily analog, meaning that everything sort of happens by hand. Everything is like plastic cast molding and then back and forth testing, recasting, all of that, and it takes a really long time. So on the left here is a carbon fiber one that the prosthetist built. And then these two are the prototype 3D prints that I did before I built my final one. Now, I only had to do 2 physical prototypes before I went to my manufactured version, and I did 51 design iterations during that. So I only had to produce 2 physical ones for 51 design iterations. And those 51 design iterations are over a space of about 8 weeks. So it's really, really fast. But to clarify that when I say 51, I don't mean 51 radically different designs, but 51 steps in the evolution of one prosthetic. Now that one on the left, she didn't actually get to use that. So there was a mistake made during the manufacturing, which meant that the socket inside was too tight and it was uncomfortable. So the result was that they wasted 12,000 euros on building this thing, and then it never got used. So when she raced in the Paralympics in London, she used a backup leg, which was a carbon fiber socket, so just a little bit of carbon fiber, and then a really heavy piece of metal, which is essentially just a stick with a pedal on the end. She still managed to get the silver, but she was at a competitive disadvantage because she didn't have something that was as light as everyone else's, and it wasn't as aerodynamic either. So we took this and went, all right, well, can we fix this? Can we make this better with digital tech? Can we make this better with the future of making things?
What was you saying again?
I can do that. So why do we do it digital? Because it's better, right? So I made a team. So there's me in the middle, Mickey, who's based in Munich, who started the project a couple of years ago. My colleague Taylor in San Francisco, and my intern at the time, who's based in Portland, and we were all working together. But the reality is that actually there were 22 of us. So there were a core team of 4, but with all the people that we collaborated with, all the co-working spaces that I sat in, all the people who gave me feedback, and of course the prosthetic engineers who were kind of holding my hand the whole way and teaching me about prosthetic engineering, because I'm not a prosthetist, but I managed to learn it in this time and build this thing. It made for a really cool way of working. And the other great thing about this was because I was working across the transatlantic, while I was asleep, they were working, and while I was working, they were asleep. So this thing was constantly moving, and that was kind of like Denise's motto, never stop spinning. So we started with this. We used a 3D scanner. We scanned her stump, and in 15 minutes, I did what takes a prosthetist 1 week. So in 15 minutes, I got it scanned, we checked it was okay, and I sent it to a 3D printer and got it back 3 days later. By the 3rd day that I got it, the prosthetist was still working on the plaster cast and making another version of it. And they finished it, when I say a week, so I mean 7 working days. So that's technically 9 days if you want to include a weekend. The next step was a concept model. So this is just the way that I work. I like to start with a concept model, something that looks kind of cool, and then building from there. Although if you know anything about aerodynamics, you know that putting holes in it is a really bad idea. But it looked cool. And then I went to Mark 1. So that first prototype that you saw, this was built a week after I got that scan. So while they got their one back and they were working on that socket version, I'd already built this in Fusion and sent it to 3D print. And what I did here was, one of the things that Denise was telling me is when she rides in different events, so whether it's on the, like she does road, track, and endurance, and they all have different bicycles and they all have different ride heights, which means she needs 3 different prosthetics. So I thought, well, can I do something modular? So I designed this thing on the bottom that she could take out and put a new one in that would change the ride height, and then we tested it out. So we took it to the prosthetic engineer studio. She tried it out. This is just 3D printed out of nylon, so it's just like standard one just to try it out for comfort, and it worked. The only thing was that the socket was not so great, so you can see it's kind of low. It should sort of come up to about here. But this was a mistake that I made because I was still learning about prosthetic engineering, and I don't speak German, and the prosthetic engineers don't speak English, so there was kind of a problem here. But it was cool, so I was like, okay, that's not a big issue. So 3 days later, I had this version, and you can see that the socket has started changing, and there were aerodynamic considerations coming in, so the shape has become a bit more asymmetrical. So this is the outside where there's more turbulence as she pedals up and down, and because she has some protection from the bike on this side. When we ran it through the wind tunnel simulation, this is what we ended up with. And then finally, we did this design. So I took that idea with the modular design, extended it, and she asked for this black and gold paint job, and I was like, all right, cool. And then added the pedal in for the simulation and this little metal piece in the bottom, which is just basically for strength and attachment. And again, just to clarify, all made in Fusion, didn't use anything else. And this is how we made it. So it's 3D printed, and then we used some like crazy CNC milling, this huge Haas industrial machine to make these tiny little pieces, and then assembled it. And there's some pictures of the paint job. So it has this gold undercoat. They got a little fancy with it. You can't really see it that far back, but it's pearlescent. So the gold kind of shines through. And I've got this video to show you, which is going to stream really horribly, I'm sorry, but I might just turn this around as well. So this is the prosthetic engineers. That's the leg she uses for walking with every day. And that's my next project with her, is to design a kind of cooler looking version of that. One of the things that she said to me is that she wants something that looks cool so that she doesn't just wear trousers all the time. She wants to wear skirts and dresses, but doesn't feel like it looks that great. So I was like, cool, let's try something out. So that thing there, by the way, I like to talk about this bit. This is, it's a valve cap. It's a super low-tech solution, but one of the things that people kind of get obsessed with, particularly students when they graduate, is everything's got to be high-tech, everything's got to be electronic. But actually, sometimes the low-tech solutions are just fine. That thing, basically what it does is, as her stump wiggles around in the prosthetic, it pushes all the air out, but the air can't get back in. So it makes a really, really nice tight fit. And it costs like €2. So I was like, all right, well, let's just get one of those and screw it on, right? Perfect. So yeah, you know, sometimes high tech is not the only way to go. So this is the first time she's trying this one on. I'm sorry about the streaming quality, and it worked. Worked first time, which was, I'm not gonna lie, even though we had all these simulations that were telling me it was gonna be fine, I was still like, oh my god, what if it doesn't work? And she did the one thing that I asked her not to do, which was the very next day she went and raced with it. We wanted to test it out some more, but the cool thing was that she won. She not only won, but she set a new personal best time, which was really cool. So I just want to give you some comparisons of this one. So the carbon fiber one that she was supposed to use was 1.2 kilos. My polycarbonate one was 1.4. It takes them 10 weeks to make one. It takes me 10 days. It cost them 12,000 euros. It cost me 3,500 pounds, 2,500 pounds. It was digitally distributable, meaning that I could work with anyone, anytime, anywhere. I had access to skills everywhere. I had a global team. And then the best stuff is that a prosthetic engineer, their workshop has to be pretty big because they need all these tools to test things like compression strength, tensile strength, alignment, gait, and bias. So one of the things that almost everyone, I'm assuming everyone in this room has both of their legs, right? Yeah. So one of just checking. One of the things that you and I take for granted is that when we stand, our weight is equally spread amongst both legs. Now the assumption is that if you're missing a limb, your body is going to compensate onto the leg that is complete. But that's not actually the case. So depending on when it happens, how old you are, who you are, all of this stuff, you may end up actually having a bias towards the bad leg, in inverted commas. And Denise is one of those people. So one of the things that we can do with simulation in the software is test how that's going to affect the limb. How when she cycles is it going to wobble, if it's going to wobble. How is her gait when she cycles? All of this stuff, things that matter at an Olympic standard, we can check it and make sure that it's going to work. But for me and for Denise, I was like, we're never going to stop spinning. So that was in December. In April, I made this one. So we took the idea and we said, well, how can we make it lighter? How can we get it more aerodynamic? And how can we make the best thing possible with the technology that we have? So you can see we shaved a lot of weight off. And we turned it into this fin design. And then in Hanover, Obama and Merkel came along and they were like, that's pretty cool. And then the whole world went crazy. It was really cool this happened, and then all these like interviews were happening for us, and it was just, it was cool. But it was just really nice to be like, oh, Obama, check my workout. That's a pretty big deal. So yeah, that new version, that's 812 grams. And what I did in 10 days, I managed to do in 2 days. So I reduced the print time, I optimized the way that the design works, and ultimately this goal of being lighter, or at least as light as possible, we didn't just break the record or match the record of 1.2 kilos. We absolutely smashed it. And none of this would have been possible without this new way of making, and more importantly, the software that I did it in. So that's me. That's what I do. I encourage everyone to give me a shout out. This is a way to get in contact with me. If you're using the software, probably the best thing to do is just take a picture of this. If you ever get stuck, regardless of, yeah, that's fine, don't worry about it. If you ever get stuck with something that you're doing in Fusion, or you have a cool idea, please share it with me. So those 3 projects that I showed you earlier on, those are 3 of about 22 that I worked with last year. And they all had like articles written and stuff. We support makers and startups as best as we can. So you know, we want to push to, if you're going to a Kickstarter, we want to make sure your Kickstarter is successful. But if you're doing something else, we also want to make sure that the right people know about you. Just to be clear, from Autodesk side, it's not about Autodesk taking over and being like, oh, they use our software. No, that's not what we're going to do. We want to talk about you as a startup. We want to talk about you and your product and your ideas. And we want to be proud of the stuff and the people that we collaborate with. So, that was a lot of talking. I'm sorry. I'm going to jump over to Fusion now. So this is oh, we manufactured it in Pier 9 in the Autodesk workshop facility. So it was really fun for me. I got to fly out. So this is what we're going to make today, or better yet, I'm going to show you. This is a laptop stand. Super simple thing. Usually I do a 3D printing tutorial, but because the laser cutter here I've been told is the most popular tool that everybody uses, I thought I would do this instead. I try to make this as light as possible so you can see how the design is. One of the other things I just like to highlight to people is that sustainability is something that's kind of important to me. And shouldn't have used MDF really because it's not a great material, but things like this to save material, minimize the weight, this is all the kind of stuff that I like to think about. I'm not going to really talk about it too much today because I just want to make sure that you guys are familiar with the software. But the point is that everyone's going to have something at the end that they can make. The reason I did a laptop stand is that usually I work with two screens. So I have a desktop screen and my laptop together, and this is how I work. Before I forget, there is one other thing I do want to just show you very quickly. So we have this other product, which is also free, called Sketchbook. And it's really great if you're someone like myself. I like to do concept drawings before I do stuff in pencil and paper before I go to the computer. But people obviously they want to know what it is that you're working on. I just wanted to show you this. So this was basically I modeled a really basic X-wing, just like a cube and then four like this, and then just drew over the top of it. And now I'm modeling this in Fusion. But the reason I'm showing it to you is like this is a really fast way to communicate ideas to people, and it's actually not that difficult. I did a 30-minute tutorial and then was able to do this afterwards. And I don't have like years of experience with Photoshop or anything. I'm really bad at digital drawing, and this was like first try. So it's actually pretty easy. Just another one that I'm doing, just to show you by comparison. It's a concept for a mouse. It was like 20 minutes, really quick doodle. I'm probably not going to make this one because I only realized after I did it that it's essentially a Microsoft Surface mouse. I think that's probably what was sort of subconsciously inspiring me. But you can see underneath, I have this Fusion model of just like the basic shape, and I brought it in and I drew over the top of it, and then I can show this to someone and be like, hey, this is probably what the final thing is going to look like. So rather than making them wait a week, they can see it in a day, right? Okay. Cool. So that's the one I made earlier. We're going to make this together. So I'm just going to... Oh, my mouse stopped working. Awesome. Sorry, 1 second. Okay, so is everyone looking at a screen like this? No, it's okay. I'll use the trackpad and then fix it afterwards. So I'm going to give you a quick rundown of how Fusion is set up, and then we're going to start making. So some of you might see a little blue thing that would be here next to your name. If it says like trial is ending in X number of days, you just need to click on that and then sign up as a startup, and then it's basically free. So we've made it really easy for it to be free. Yeah. You only have to start paying for Fusion if your company has a turnover of greater than $100,000. So, and then when you do have to pay for it, it's $350 a year, I think. So it's really not a lot at all. Is it gonna work? No, mouse is still dead. Okay, cool. Nope, still nothing. I'm gonna try it one more time. Nope. All right. It's all right. I'll use a trackpad. Okay. So at first glance, basically what you're seeing, this is your model spaces where you're going to do 90% of everything. You have a cube in the top right, which is a navigation cube. You can use this to pan and move around, and just you can press on the different faces on it as well to get different views. Or if you prefer, if you're using a mouse, if you hold down Shift and the middle mouse button, that rotates. If you're on a trackpad, then on a Mac, you can pinch to zoom, and with 2 fingers you can pan, and then 2 fingers and Shift you can rotate the same way. The workspace is broken down into these 6 main workspaces. So model patch, model is solid modeling, patch is surface modeling. If you don't know the difference, basically, if I make a cube in model and chop it in half, and then look at it, you'll see that it's solid. If I do it in the patch environment and chop it in half, it has no internal volume. So it's just the faces of the cube. There are reasons that you would use each one for different scenarios, but with Fusion, because Fusion is pretty smart, you'll do almost everything with the model space. Rendering is rendering. Animation, you're not going to make the next Toy Story, but if you want to show how something is disassembled, it's super easy. There's like a 1-button explode, and it will just disassemble your model for you. Simulation, you don't have to be an engineer to use simulation. It's actually pretty easy. So I recommend that everyone gives it a try at some point. It will do static and modular, and then thermal and thermal stress. So if you don't know what that means, basically static is doing this, modular is doing this, thermal is taking a hairdryer to it, and then thermal stress is taking a hairdryer to it and pressing on it at the same time. It's pretty easy. Good thing to do usually is like, well, if we've got time, I'll do one with the laptop stand and basically just apply a force to it to see how it's going to behave with the weight of a laptop and then my hands resting on it. Obviously, you can see it's fine. There is one extra space which is slightly hidden, and that is the T-spline space. So under Create, you can see there is Create Form. You don't need to do this right now if you just watch my screen. The Create Form is a T-spline's environment. It's basically for creating organic form. So, for example, if I start with this cube, it basically acts like clay, and you can grab it and just move it around and really like mess around with it. This is really great for car design. This is how I built the prosthetic as well. So I used a combination of standard modeling and T-spline modeling. It's super, super easy, and we have loads of great tutorials on our YouTube channel. Although the thing that I just made was broken, so it won't work. Okay, let me try my mouse one last time. Oh, there we go. Woohoo! Cool. Okay. All right. So let's start building this thing. So the way that I built it was I started with a 2D drawing and then built it parametrically, which means that if I want to go back and change it later on, it's super easy to do that. So to do that, what we're going to do is go to Sketch and then Create Sketch. That screen is not super helpful. It's probably really just kind of more of a guide than it is anything else right now. But we're going to do that, and then you'll see that the 3 planes are going to show up, so these orange squares. I'm going to start with this one here, which is the right plane, or the Y plane, if you prefer. So it's this vertical one. If you can't see it that well, it's this one here. Oh, that's better. Thank you. So I'm just going to click on that, and as soon as I click on it, it's going to jump to this 2D view. If anyone gets stuck at any point or you make a mistake, please just give me a shout, and I will help out. In fact, I should just see if we have any questions yet. Nope. All right, we're good. Okay, so I'm going to show you first, and then we'll do it together. Basically, what I'm going to do is go to Sketch and then Line. So if you just watch me do it, we'll do it together. And basically, I'm just going to draw 3 lines. Well, I'm going to draw my overall like rough shape. I'm not really paying attention to to dimensions at all right now. So we're going to do that. Or actually, you know what? I'll just leave that on the screen, and you guys can just copy it. So if you need to find the tool, it's under Sketch and Line. And then you just want to draw something that looks approximately like this. Don't start adding dimensions yet. Too keen. Yep. Everyone good? Okay. So basically, the reason I did it this way is that it's much faster to draw it and then add the dimensions and constraints in afterwards, and it also makes it a little bit neater in the long run. So first thing I've got this little bit of extra line on my one there, which I don't want. So if I press S on the keyboard, it brings up the search tool, and then if I start typing trim, you can see you get the trim tool. I'm just going to click on that, and then I'm going to highlight this piece of my line, and you'll see it highlights it in red, and then I just click once, and it's gone. That's it. And then I can just hit escape on the keyboard to finish using the tool. Something that's kind of important though, just in case you don't have it, you can see inside the borders of my drawing, it's filled in that kind of weird orangey beige color. That's basically Fusion telling you that what you've created is a closed loop, so that when you go to create it in 3D, it's actually going to create a solid piece. If you don't have that, you need to find where the hole is and plug it, but I think everyone is okay. So next we're going to start adding in some dimensions to this. So first off, to do that, if I go to Sketch, I'll go down to Sketch Dimension, or you can just press D on the keyboard. You can see that some of the tools have a letter next to them. That's their keyboard shortcut. Alternatively, if you ever can't find a tool, the same way that I did it with trim, if I press S and then start typing in, you can see that it will bring up the tools. All right, so I'm going to start adding in a few dimensions here. First one I'm going to start with is the angle, because to me that's the most important thing. So I want to make sure that this angle on my laptop stand is good. I've kind of tailored this to my preferences, so for me 22 degrees is what I like. So to put that in, it's really easy. I just click on that bottom line, and then it's going to start adding a dimension in already, but if I click on the second line up there, it's going to change it to a degree. And then I just type 22, which is what I want, and press enter. And you can see it's shifted that up there, and it's giving me that 22 degrees. Next, obviously, the overall length's pretty important. So that base length there, that's 460 mil right now, which is obviously way too big. So I've just clicked on the bottom line, dragged it down, and clicked again. And I'm going to make this 225. And then press enter. And you can see it's gone a bit weird. We don't have to worry about that right now. I'm going to fix that later. So actually, one of the things that I can do right now to sort of mend this is if I hit escape and I grab that corner, I can drag it and it'll just sort of approximately change. So can you see that that bottom one isn't changing and that degree is staying the same the whole time, right? So when you add these constraints in, it's always, they're basically locked. So if you start pulling around on these ones, like as I move this around, like I can grab that one and do the same thing, it's going to move wherever, like this angle, but this piece here is not going to change because it's been constrained. With the sketch dimension. So I'm gonna do that. So that's fine because I'm gonna fix this later. So next, I want to add this overall height because clearly that's going to be way too high up. So I'm going to add a dimension in here. So 245 is way too high. It would be like up here. I don't want that. So I'm going to change that to 125. And again, this bit's gone really fudged. So I'm just gonna grab that and just move that over here, and that's too low down. I'll do that, and then I'm just gonna grab that one and put it over there. That's sort of what it should look like. Next, I'm gonna add. I want this overall height here, so this vertical height. So again, excuse me. If I press D on the keyboard, and then if I click on this line, just to show you this, so by default, Fusion is going to show you the orthographic distances. So if I pull it this way, and I pull it this way, it's showing the X length and then the Y length. But if I want the correct length, in this case I actually don't want it, but if in the future you want to find out what that is, you basically just click somewhere near it, and then it'll do it. Okay? And then if I want to change it back, well, click too fast. But for the time being, I just want this one. And I want that horizontal, because it's just the way that I think about it. And one of the things I like to highlight to people is that there is no wrong way to 3D model. There are definitely faster ways, but whatever works in your brain's logic, right? So I want that overall height to be 55. Okay. And again, you can see that it's kind of gone a bit mental. The reason it's gone mental is because I've not added constraints in here. So one of the things that I could do right now, has everyone got these 4 in? No? Has it just gone? Okay, so you're obviously in there. Okay. Okay, cool. Cool. All right, everyone's sort of approximately got the correct thing. So next, am I going too fast? No?
I was kind of wandering around there.
Yeah? Okay, good.
I might have the wrong face.
That's fine. That's not an issue.
What is this create sketch dimension or sketch?
Oh, is it just sort of hovering there? You just click away? No? Oh, you stop the sketch, that's fine.
Okay.
Yeah, that's sort of important actually. So you can see here, right now you should all have this thing that says stop sketch. So when you're doing something 2D, you're in this sort of 2D workspace. And when you step out of 2D, it jumps back into 3D. So a common mistake that beginners make is that they might accidentally stop the sketch and then go create sketch. And that's going to end up making a new one. It's not going to be linked to the one that you were working on, so just be aware of that. You can see down here, there's this timeline, and currently only has one function in it. We're going to do some stuff with the timeline later on, but one of my favorite things about the timeline is that it makes iterating really, really easy. So if you're making a box, and your box is part of another assembly, and then someone says to you, oh, we want the overall height to go from 55 to 35. If you, like me, you were working in Rhino, that pretty much means you sort of have to scrap everything around it and do it again. But with Fusion, you just go back to that step and just edit it and go change that dimension, and then it recalculates everything that was related to it and fixes and updates it. So this one, this laptop stand is actually something that my colleague made, and his version of it was a lot simpler, and I didn't really like it aesthetically, so I took his and made this one, but now we're building this one from scratch. And that's why I made this tutorial. Okay. So, there are a couple things that I want to do here. So you can see on my one that I have these little white squares in the corners. And this symbol is basically saying that these two angles here are 90 degrees. And it's possible to add these in addition. So what I'm going to do is this thing over here in the sketch palette, you can see that one of them says perpendicular, right? Yeah? So you click on the one that says perpendicular, and then the way that it works is, so I want to make this like that, right? I want this to be 90 degrees, and then I want this line to be perpendicular this way, right? So it's super easy. All I got to do is click here, and then here, and that's changed, right?
Can you do that again?
Yep. So in the sketch palette, I click on the one that says perpendicular, and then I click on the line, this one, and then this one, and that changes that to be perpendicular. Now, one of the things that I've noticed here is that these two lines here are not parallel, this one, and I want these two to be parallel. So next up, I just go over to parallel, and then click on this one, and then click on this one, and that just makes those two parallel. Super, super easy.
Which one does it?
It'll make it relative to the one you click on first. So after that, this little bit here, this massive tab, that's obviously meant to be to. I have one. Sorry. That thing there is this little tiny piece here. This little end stop for my laptop. So clearly that's massive. That doesn't need to be that big. So what I'm going to do is add a dimension. So if I just click in the space and then press D on the keyboard, can you see the icon next to my mouse has changed as well? And that lets you know that you're in the correct tool. So I'm just going to click on that line and draw up. And again, I'm going to use the vertical one here, and I'm going to change that to be 15. Now you can see the whole thing is changed up, right? It was easy. So you got the overall shape. Is everyone up to speed? Does anyone need a hand? Anyone need me to catch them up? The 15? Yeah. So I think you also need to add in your perpendiculars. So yeah, good. And then click again first. Yeah, and then again. I'm going to do it again. And then yeah, and then no, it seems to be. It shouldn't be cancelling, but if you just do it again.
Yeah.
And then if you press D on the keyboard, and then you want to click this end piece. Yeah.
No,
no,
but not the center point.
You're clicking the center point. Yeah,
Click
there.
just off the center.
And then just move your mouse up. And then 15. Yeah.
Okay.
Oh, your whole thing is massive though. So you just need to add those other dimensions in. So yeah, that one is 225. Just zoom in. And the vertical is 125.
This one.
Mm-hmm. And then that line, the outer line, that's the inner one. And then D. Yeah. That's 55. And then you need to add the angle from, yeah, so click that one first. And then click the baseline as well.
I don't know how.
No, it's, yeah, so click that one, and then press D.
Let's do.
And click there, and then click the other one, yeah. That's it, and then change that to 22. Great, all right, there we go. Okay. So before we continue, obviously I've decided that I want to laser cut this. So one of the things that you have to consider is the thickness of the laser ply. So on this one, you can see that I have slots, and I also, the slots here are the thickness of my laser ply. Now, this is 6 millimeters, and I could just type 6 millimeters when I make this, but actually what I want to do is set that up to be parametrically controlled. Because actually when I modeled this, because my colleague in America made it, it was in Imperial, and when I came to make it here, they had 6 mil stuff, and it was very easy for me to change it, and then when I change that thickness, it also changes how all these slots are related to each other, so I don't have to redraw all that stuff. So we're going to do that together, and that, again, really simple. So under Modify, right at the bottom, there is something called Change Parameters, and I'm going to click on that, and in here, you can see one of them says User Parameters. Now, with a user parameter, what I can do is define something that basically acts as like X. And then I can change it as many times as I want afterwards, and it updates everything that it's related to. So I'm going to call this ply. And then expression is, so basically what this means is, so the unit is the unit, whatever you decide that unit is. You can actually see all the different ones here. So you can go down to microns, you can use nautical miles if you want to use nautical miles. You can actually use currency as well, although the only currency is currently dollars, because apparently that's the only one that matters. Temperature, time, solid angle, speed, pressure, for loads and loads and loads of different ones. I'm going to leave it as millimeters. So the expression when I type 3 is basically 3 millimeters. That's what that means. You can leave a comment for yourself as well. I'm going to leave a comment that just says this is the wood thickness definition. And then just hit OK. And then I hit OK here. So I'm going to finish eating before I... What I'm going to do now with you guys is make this here, right? They're really easy, but we're going to use that thing that we just made to make these end pieces. Okay. So what I'm going to do is under Sketch, I'm going to go to Offset. Yep. Now, when I start the offset, you can see that I've got this little dialog box, and this is basically just giving me some controls that I can deal with. Yours here, can you see that there is no tick in my chain selection window? Make sure that that's switched off. Just to show you what that means, like if I have chain selection on and I click, it's going to pick everything, because it's going to pick everything that's connected to one another. If I do that and then offset it, it's going to offset the whole thing. But I don't want to do that. I want chain selection off, so that when I select that line, it only selects that line, right? So basically, just make sure that's off, and then select that line here that we looked at. And here, where it's telling you the distance, so mine currently says 13.76, I'm going to type ply. You can see it's giving me a little pop-up telling me that that's a user parameter. So now I'm just going to click on that, and then press OK. And you can see that's set to 3. Now, if I want to make it 6, which is what this one is made from, all I'm going to do is go back to Modify and change parameter. Whoops, keep clicking too quickly. If I go back to modify and change parameters, here in my user parameter where it says an expression of 3, I just double click on that guy and then change that to 6. And if I press enter now and press OK, this guy, yeah, come on, there we go. All right, wasn't doing it properly. Okay, so I seem to have made a mistake, but usually what happens is when you change that parameter, it updates everything. So if yours hasn't done that, just double click where it says 3. And then put -ply instead.
Is there any command that you can apply, deploy once again all the user parameters, the whole object?
Oh, to everything?
Yes.
No.
Probably they usually update automatically.
Yeah, they update automatically. So I don't know why it didn't. Now my one says FX6. So if I go back and change that, it should update. So if I change that to 3. Yeah, there we go. Now it's working. So if I type 6 this time, yeah, can you see that's up? That's jumping around. Like if I change that quite a lot. Yep. You can also use maths with these. So if I change that to back to 6, if I double click on this guy that says 6, I can do ply times 2, and that's going to make it 12. Right? You can also do like sine, cos, tan, and logarithmic if you want to. I've personally never had any reason to do that, but it's there. It's better to have it than and not need it than need it and not have it. So I'm just going to change that back to ply. Okay. All right. So now we just need to add some lines for the actual. Yeah.
Yeah.
Hang on. So it has a prefix FX. It's usually fine.
Yeah.
Yeah. Okay.
Right, I'll try changing it to see if it's.
Oh, what does this taste like?
Okay, so if you select, so you want to make this button, if you select the escape, select.
All right, cool. So we're going to add, obviously, the pegs in. So what I'm going to do is, if I press L on the keyboard for line, and the line down here, which is part of the actual laptop stand, can you see that as I'm hovering over it, there's a blue X? That X is the symbol for intersection. I'm going to keep moving until I get to the middle. So my middle is there, and you can see that X now has a blue triangle next to it as well. So once you get to the middle of the line, you'll see this blue triangle. That blue triangle is the symbol for midpoint. And I'm going to click here once, and then I'm going to start moving my mouse out, and you can see, you can just about make out that there is also a blue square there, and that's telling me that that line is perpendicular. right? If you can't see that, then you could just draw something like this, and then afterwards go perpendicular from here to here, and that's just going to make that 90 degrees as well. Yeah? Cool. So what I'm going to do with that one is I'm just going to go to offset again, and so my sketch curves, I haven't selected anything, but chain selection is off, and I'm going to pick this one, and I'm just going to move it. I'm going to move it, yeah, 50 millimeters this way, and then just press OK. So I went to offset, and I changed that to 50 and pressed OK. And then what I'm going to do is, this is kind of important. You can see this symbol here is the symbol for offset. So currently those two lines are parametrically linked, right? I don't want that parametric link right now, so I'm just going to select it and then press delete, right? Am I going too fast? Do you need me to? Here? These are all 90. That's 90, 90, 90, but that was using the perpendicular.
But the bottom.
Oh, here?
The bottom part, yeah.
No, I don't have. I haven't put an angle. I don't need to put one in. So now I'm going to create another offset from this one to the next one. The reason that I deleted that first parametric offset is that you can't stack parametric offset. So if I go offset and then offset from the offset, it doesn't like it. We're actually going to update that so you can link them, but right now it's just like, doesn't know what to do mathematically yet. So if I'm just press O for offset again, and this time I'm going to just move it this way, and then I'm going to start typing ply, and then do ×3, and press OK.
The second line, right?
Yeah, so selected this one and moved it across, and you can see mine says FX18. Oh, do you have these little symbols that look like this? The little kind of cloud thing? You want to select that and press delete.
I don't.
You don't have that?
No.
But is it working or not?
No. I didn't do the offset thing because I was troubled with my previous. I just drew. You can't offset.
That works too.
Well, but then you didn't, because that is the constraint. The cloud is the symbol for the offset.
But the line is just like a visual.
The line?
Like the line. That's no. I mean the thing that actually says the measurement. So I deleted that, but didn't
that's the dimension constraint. But there's also those symbols next to it, like here. That's offset. That's the dimension, but that's the offset. And like here, there's perpendicular, and well, there's the midpoint. Like that took me a while to understand that you really. It's good to know what they are and don't ignore them. Yeah. So that one's okay because you're using it.
Oh, well, you're doing pretty good.
Yeah, it's really good to know that. I just ignored it and would do my own things, and then all of a sudden you're trying to move some stuff around, and everything turns because they're constrained.
What's the option?
It was
5×3.
Yeah.
Using 6 mm plywood or
Yeah.
6.
And here, oh wait, if you don't click it yet, when that arrow there, if you click it, it'll like put it up here. It's like a shortcut.
This is not an
You should have done it.
Don't worry, I have
Yeah.
English keyboard.
And you can remove it also in the same way.
English.
That's also handy.
It's a nightmare. I found in the app, isn't it? Okay.
All right.
How did you start this offset? On this one, you can do more like more.
So if you double click that one where it says 9, And then, times 9. Yeah. Let me just press enter. There you go. Alright, cool, okay. So next thing we're going to do is this line here that we used, I'm going to use that as my mirror line, right? So what I'm going to do is, can you see that, can you see right now my sketch palette, there's just this number of tools, right? Now when I click on my line, can you see this extra one appears? There's this extra one at the top. This is normal/construction. So basically that's a toggle switch to turn it from a normal line into a construction line. The difference between a normal line and a construction line is that the construction line is just for reference. So just to demonstrate to you, I'll just show you here. If I create a sketch, I'm just creating a sketch in another drawing. I'm going to make a rectangle, and that rectangle is solid, right? So it works as you expect. But if I pick one of the lines and I change it to construction, can you see that it emptied it? Because it's not a solid anymore. That's basically, this line is just a reference line for doing things like offsets and creating mirrors and stuff like that. It doesn't have any actual bearing on your model. You guys okay with that? Yeah, all right. So when I pick this line here, it's here in the sketch palette. It's right at the top.
Can you put surface also as a construction?
We actually have like separate construction tools for that. So I'm just going to select it. So when I click on it, it changes my line from a blue line into that dashed orange one. So, and if I want to change it back, I just click on it and do that again, and it just turns it back. But I'm going to leave that as a construction line. And then what I'm going to do is go under sketch and then to mirror. And then pick mirror. And first it says, so you can see right now it says object select. So I'm going to click this line and this line. And then here where it says mirror line, I'm going to click in the mouse area that says select. So it's highlighted that bit blue. And then just pick that construction line that I created. And now press OK. All right, pretty simple. Everyone got that? Yeah. So next, I'm going to go to sketch and then trim. And with trim, what I can do is basically cut all those extra bits of line off. So just like before, so if I highlight this one, it turns red. So I'm just going to click on these extra pieces here and just chop them off. And then down here as well, I'm going to get rid of that bit in the middle and that bit there. All right? Yep. So when you're done, you should be left with something that looks like this. Just bear in mind that I also got rid of the piece down here. Yeah? In between the tabs. I'm going to eat all this candy on my own.
I still got the this 50 millimeter.
That's okay.
It's okay.
Is there a fast way to delete all the constraints? Just make them disappear? No.
You.
I'm good at asking these questions. Shift on that one. Wait, but did you have apply with a big P? Does that matter as well? Like, yeah, see where it pops up? You can hit enter. Yeah.
Here, the dimensions were those.
Yeah.
These ones?
Yeah.
So this will just apply.
Yeah, but like
Make that
where are they on this line? Yeah. Like where they're situated.
Yeah, everything here is fine.
I think it's the correct length one.
Yeah, because it's just from the middle bit here.
Yeah.
So,
This is the middle bit,
Mhm.
for sure. Okay.
I mean, if it's not, then what you can always do is just, well, it is now.
Okay.
Yeah, you're fine.
I don't know how.
Then just trim everything else away like extra pieces here. The T is the shortcut. Trim. Yeah.
Okay, that's good. Right, so this
Yeah,
thing is going to
yeah.
overconstrain. That's good.
You want these tabs, but not that. No, you want that. Or you want that part, yeah. So delete this line here, yeah. And the one there. Stuff. And then also underneath. And those two, I guess.
Cool. All right.
Okay.
Great. Okay.
Yeah.
I'm aware of time, and I don't want to keep you here forever. So my one has all these like extra cutout pieces. We won't model that now. We'll jump through to making something 3D, and then making the top, so people can go home. So basically, this is done. So just press stop sketch. So when you hit stop sketch, it'll come back to this 3D. I actually just realized that there is one extra thing to do. My bad. So it's really easy to go back to the sketch. Down in the bottom left, you should see a little sketch icon in your timeline. And if you just right-click on it and go to Edit Sketch, and that's going to return you to your drawing. So the one thing I just want to do is, it's not a big deal, but for me it's just something that I like, is I want this bottom corner here to be in line with my origin on my coordinates here. So all I'm going to do is, at the top I have a constraint that's called coincident, and coincident is basically where two things touch. So I'm going to click on coincident, and I'm going to click my little bottom corner point, and then take it over here, and it's telling me I can't do that for some reason. How can I do that? Genuinely no idea why I can't do that. Because of this. Weird. Can you move it? Yeah, I can move the whole thing, so why can't I? Oh, I can always just do it. Whoa, okay, that's why.
Why?
Something is...
Oh.
Yeah.
There's
It's,
a constraint somewhere.
there's a constraint I haven't added yet. Screw it, it's fine where it is.
Well, I got a point-to-point now. Can we do that?
Point-to-point move only works on 3D stuff.
Oh, okay.
It's fine. I don't want to rush. I don't want to be here forever. Or I don't want you to be here forever. I'm fine being here forever. So you need to give this a thickness. So to give it a thickness, we just go under Create and then Extrude. And you can see there's that little pop-up. Basically, if you're ever working on your own and you're not sure what a tool does, you can see as I'm hovering over the tool, it gives you that window that just sort of explains what it does. So I'm just going to go Create, Extrude, click on that, click on the profile that I just created, and then here for the thickness, I'm just going to type Ply. And then press OK. So the distance is set to Ply. Now, if you all hit OK, if you just look at my screen, one of the other things you can do with the extrusion tool is, if I just start pulling that out, you can add a taper. So you can start tapering things right from the get-go. So if you ever need it, it's there. You can also do a two-sided extrusion, so you can extrude in two direct asymmetrical distances, or you can set a symmetric, so it just does the same on both sides. It's just handy. I mean, it's there. I use the symmetric and the two-sided quite a lot. I almost never use the taper. But with the taper. Oh, whoops! Hang
Got
on.
some air vents ready.
What, like that? Sort of. It looks like something you should keep a Torah on.
Assembling that's a bit more work.
Yeah. So once you got that, just hit OK. And then what I'm going to do next is, before I do the next step, I just want to convert this from a body into a component. Do you need a hand with something? The? Oh, the taper angle? It's here, where it says taper angle. It's just under distance. Cool. So next what I'm going to do is I'm going to convert this from a body into a component. So basically the difference between them is that bodies are 3D geometries that are work in progress, and components are when you start to create assemblies. So if you're not sure what an assembly is, it's an assembly because it's a bunch of stuff that's been assembled. It seems kind of straightforward, but some people don't get that, so I just like to say it. And then assemblies can have sub-assemblies, so pretty much anything other than a laptop stand will definitely have sub-assemblies. My laptop definitely has sub-assemblies, so the chassis is an assembly, and then the sub-assemblies would be, for example, the LCD monitor is made of the glass, the screen, the blah, 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 blah. But it's an assembly of my laptop. Does that make sense? It's like categories and subcategories. I may have just given away that I read really weird books there, but cool. Okay, so what I'm going to do to turn this into a component is I'm just going to go under Assemble, and there is New Component. So I just click where it says New Component, and that's going to bring this guy up, and it's going to say Empty Component or From Bodies. So I'm going to click where it says From Bodies, and then I'm going to select this guy, and then just press OK. Right? So From Bodies, select that, press OK, and then I'm going to double click on this guy that says Component 1.1. I'm just going to double click on it and then just change the name to leg. Okay, so you should see now your timeline has a bit more stuff in it, and also this guy up here in the top left, that's called your browser. So has everyone here used Photoshop before? Yeah, so you're familiar with layers. So Fusion doesn't use layers. It actually just automatically categorizes everything for you, which I find a lot easier. So everything 2D is in a 2D folder called Sketches. Everything 3D is in a 3D folder called Bodies. Components have their own folders, and it just does it for you. So you don't have to think about it, which is great. So it just keeps it nice and clean. One of the other things about Fusion that I haven't shown you quite just yet is this thing here, which is called the data panel. So this little grid of 9, this is where all your projects sit. So yours is probably only got one that is your name and then this is first project, right? And then some sample ones. You can see here, these are all the different projects that I'm in. So anything with a little green head next to it is something that somebody else has added me to. So I'm not kidding when I say that I will help you out. Like these are, every green one here is another person's project that I'm supporting. And there's Shaolu. There's Jason. Cool. So
Yeah, and that's for real. I called him once, and then he was like, or I was asking for just something simple, and then he's like, okay, we'll like Skype or something, and did the screen sharing, and he showed me how to do it and explained how to do it, and solved my problem like super fast. That was really nice.
You're welcome.
Thank you.
All right. So I just want to bring this across so that I've obviously got 2 legs on my table. So I'm just going to right-click on the component, and go copy, and then right click in the space and go paste down here, right? And then this basically, you can see when I click on the front face of my cube, you can see that the navigation point is set to the middle of the body, which for me, I prefer. Like some people, when they move stuff in a 3D space, they think of corner to corner or edge to edge. Me personally, I like to think center to center. It's just how I've been educated. So that's what I'm going to teach you guys. So basically, what I'm going to do is, now that I'm in this front view, so if you just click where it says front on the cube, that takes you to this view. And I'm going to grab that arrow and just start moving it. And as I move it, it's giving me that distance. So the distance that I made my laptop here across the base is 280. So it's slightly smaller than my laptop is. This doesn't actually need to cover the entire base. As long as it's wide enough that it's stable and wide enough that this isn't going to, you know, counterbalance, or if I was like working and I rested on one side and it starts lifting up, as long as it's not doing that, it's good enough. And that also helps you save a little bit of MDF so you can fit more on your sheet. So I'm going to make that distance 280 and then just press OK. Cool. All right. So we're nearly done. Just got to add a top. So you can see we've got this bit, and we want to add something that lines up with that. Now, if I go back to Sketch and create Sketch, I can pick one of the grid points on my origin over here, or I can pick one of the faces. So it can actually select one of these faces, and it's going to change it to that angle. But I don't want to do that. I'm just saying that you can. What I want to actually do is go here under Construct and go to Offset Plane. And the only reason I'm doing this is to show you that the construction tools exist. These are super, super helpful. So you remember when I changed that line to a construction line and it turned into a dashed orange thing? This is essentially an entire tool set for doing that in 3D. So if you're just starting out, this might look kind of nuts, and you probably don't understand what most of them mean. When I started with Fusion, I didn't know what most of them meant because I'd worked for years in a program that didn't have this. It was you just didn't have it, which is not very helpful in retrospect. But to be honest with you, in the 3 years that I've been using Fusion, I use maybe 25% of these. So I use offset plane, plane at angle, tangent plane, mid plane, and then axis. I don't really use the other ones, but they're helpful. They're there. It's not that these are more advanced. It's really just sort of how do you think? Like, what is your logic path, and us trying to cater to it. So I'm just going to pick offset plane. So the first one, so construct and then offset plane. And I'm going to highlight that same face. And you'll see that it's made this orange square, right? Now the reason that I did it this way is that I want this big orange square as a reference point in the future when I'm working. That's pretty much it. That's why I have it. Okay? So just do that. You want a distance of 0. But one of the handy things with using construction plane is that I can actually grab this and just offset it. So if I ever wanted to make something that was at an angle, or maybe at an angled intersection internally, that's really helpful. I'm just going to set that to 0. And then just press OK. You'll be pleased to know that the top is actually very easy to make. It's not as complicated as this. It's pretty much just a square. One of the things that you can also do with the construction plane is you can change its size. So I can grab an edge and just pull it across and then move it down. This is basically just a visual cue because the construction plane doesn't have any dimension. It's just a visual reference. But it's just some people find it helpful for it to be smaller. Some people like it to be bigger. I like mine to be nice and big so I know where it is and I don't lose it. So with that done, I'm just going to go to Sketch, create Sketch, and I'm going to click on this guy. So you can see that it's moved it to that angle, right? So don't do this with your one, but I'm going to rotate mine around, and you can see that the grid is at the angle. So that's the way the 2D drawing is being made. I can move mine back. I've just got to go look at. And there we go. So if you do actually ever get stuck, like if you'll do something like this and you lose your drawing, first off, you can just, if you hover over the cube, there's a little home button. The home button just brings you back. And when you're in 2D, obviously, like you're drawing, but I'm not drawing with an orthographic view. Under options, there's that one that says look at, and that's just going to change it back to that default view. So those two are just handy things. You want to use offset plane, the first one, and then highlight, yeah, and then just press OK, and then go to create sketch, right at the top.
Okay, so that one's cool. Yeah.
And then select that construction plane. There we go. All right, cool. So to make the rectangle, I'm just going to make life easy for myself. And what I'm going to do is I'm going to draw a line. So I'm going to go to Sketch, Line. And by the way, just another handy thing. I know I'm throwing a huge amount of information at you, but if you go to the YouTube channel, there are tutorials. My channel has a different intro tutorial where I just explain everything, and obviously you can pause it. You can't pause me because you don't control me. But one of the things that you can do is, can you see next to the ellipse tool there, it has that little upswing arrow? And basically, if I click on that, it just adds it up here. So if you want quick access to your tools, you can just throw them up there. It's just a handy thing to know. The same with the sketch tool, by the way, that search tool. So when I press S, you can see it has 3 tools here. If I start typing trim, and then I hover over trim, I can do the same thing, and it adds it there. And this box, by the way, this box is context aware. So when I'm working in 2D, it only shows me the 2D stuff in that context in the toolbox. When I go to 3D, it shows me the 3D, and so on and so forth. So it's a pretty handy tool. Yeah. Oh, if you lost. Yeah. Just there where it says look at in the sketch palette. Just click on that, and it'll jump back. There you go. Okay, so basically what I'm going to do here, you can see that Fusion will automatically detect the 3D geometry even though you're working in 2D. So when I go to this top left corner, it understands that I'm highlighting the endpoint of that piece there. So I'm going to click there, and then I'm just going to bring it down, and I'm going to bring it down to this end, not the very bottom right, but just at the tip of the rectangle, because that tip of the rectangle that I'm seeing in 2D is basically that, right? So I want this inside corner. So with that selected, I'm just going to click, and then I'm going to hit escape. And then I'm going to click on this circle. I'm going to click on this line, and I'm going to change that to a construction as well. Now the reason that I did this is that the middle of this is the center of my laptop stand. So what I can do now under Sketch, if I go to Rectangle, there is a tool called Center Rectangle. So I'm going to click on Center Rectangle, and then I'm going to hover over this line, and when I get to the middle of it, you can see I've got the blue triangle again, right? So now I can just click once, and as I move it out, it basically draws the rectangle from that center point. So if I highlight here, you can see that it's 286, which is the distance I made it, by 239.264. So actually this one here that says 239.264, I want that to stay the same. So I'm going to leave that one, but I want this one to be a bit wider. So I'm going to change that from 286 to 320. And if you're wondering how you do that, so if I do this, I'm going to lose those dimensions. If I hover back here to that corner, if I just press Tab, I just jump between different distances. So I want that bottom one. I don't want to change the vertical, I just want to change the horizontal. And I'm going to change that to 310. And maybe a bit wider, actually. Maybe 320.
Sorry, what did you click on to get the dimensions down?
Oh, you've actually drawn it. I haven't actually drawn mine. So
Okay.
just, yeah.
What's this lock?
So the lock key basically has locked that dimension in. So if you want to change it, you actually have to click in it and change it there. So yeah, because now mine is 320 at the base. Now if I hit tab, there's a little lock key next to where I type 320 because I actually put an entry in manually. So now if I move it up and down again, I can't move it left or right, but I can move it up or down, which for me is not a problem because I just highlight that corner again. Nope. Come on. Oh, wait, hang on. Sorry, I'm doing it the wrong way. Cool. So now, wait, hang on, mine isn't locking in. It's doing something weird. Oh, it's trying to highlight that. Oh, okay, I see what's happening. It's my bad. Hang on, I'm just.
How does it work with the snaps? Can you change with the keyboard shortcut?
Oh, can you turn the snaps off?
Yeah.
Actually, no. I'm not sure why. I imagine that will change. So one of the kind of handy things is, so I'm going to type 320 here. Oh, wrong one. Yeah, 320. And just press enter. Okay, cool. So one of the things that Fusion does is we update it every 6 weeks. So we add new features every 6 weeks. But if there's a functionality that you want, if you click here in the top left where the question mark is, there is a, something that says submit an idea. And we do actually listen. It's not just there for show. So when we roll out updates, we also put there's an updates update, which basically tells you what we've added. And some of them will have a little light bulb next to them, and the ones that have a light bulb is things that the community has suggested. And if you get really good with it, or if you get sort of higher profile, the product managers will actually reach out to you, and they'll tell you what it is that we're adding and what your priorities are. So if there's something that you want more, they'll ask you. Obviously, they're not going to ask only you. They ask a few thousand people around the world. Sorry, Aaron, I'm busy. Excuse me. Just need to change that to say that I'm busy. How do I tell it I'm busy? Why is this so hard? Oh, forget. Oh wait, right there. I'll talk to you later. All right. With that rectangle done, just hit stop sketch. And now we're going to extrude that. So go to create and then extrude. And pick the surface. Now, you'll notice this time that when you type ply for the distance, what the hell? That's new. I'll try that again. Oh, that's really weird. All right, well,
Looks like it's doing the mirroring.
I'm having a bug. Well, it works. Oh, well, it's supposed to go that way anyway. It's in the minus direction, so I'm just minus ply. So you'll notice that the operation. Are you moving it in? If you move it down this way, that Yeah, so sorry, I realize why it's doing that. If I do it this way, can you see it says join? If I change that to say new body, it's not going to do that anymore. It's to do with this copy paste. So the distance here is going to be minus pi, but before you hit OK, it's going to try and do this. It's going to try and cut it. The reason it's going to try and cut it is that it's detected those pegs, and when Fusion basically sees one geometry being pushed into another one, it assumes that what you're trying to do is cut away. Now, 99% of the time, it's correct. You do actually want to cut away, but in this case, I don't. So where it says operation, you can see there are a few other options. Like I could say join, which is making it go weird. I can do intersect, and intersect basically just leaves the geometry that's left between the two ones, so it would only be the 4 pegs. In our case, we want just a new body, just going to ignore all of that, and it's just going to make 2 geometries that collide with each other, and then just press OK. And next, what we're going to do is under Modify, there's a tool called Combine, which is a Boolean tool, if anyone knows what Boolean means. If you don't worry about it. That's why we called it Combine. Just makes it easier. So we go to Combine, and then under Combine, we're going to use the operation called Cut. So here we've got target body and we've got tool bodies. So when you're using the cut, the target body is the piece that you want stuff cut away from, so this one. The tool bodies are the pieces you're using to do the cut with, which is this and this. Now you'll see here, there's an option that says Keep Tools. One of the things that Fusion can do is, if you're using tool bodies to make a cut, sometimes you want to get rid of that geometry that you use to make the cut with. That'll automatically delete it as part of that function. We don't want to do that, otherwise we're just going to be left with a plank of wood and no legs. So I'm going to turn Keep Tools on and then press OK. Now, the model doesn't look any different, right? But if I just, in my timeline at the bottom here, if I just rewind one step before that combine, and under Inspect there is a tool called Interference. You don't have to do this. This is just to show you. This tool that says Interference, basically what that will do is it'll find out where geometries are colliding and that would cause an issue. So in 3D, it's fine, but in the physical world, that wouldn't work, right? So I just do this thing, I hit compute, and it's immediately just showing me like, well, those 4 areas are a problem. So you need to chop something away. So that's why we did that combine to begin with. So now if I go back and do it again, no interference is detected, right? It means that the cut worked. Okay, all right. So last thing we want to do is we want to convert this piece into a component as well. So to do that, just in the same place where it says New Component, I'm going to pick From Bodies again and pick this one, and then just press OK. And now I have my 3 components. And that's one last thing we've got to just add is just a cross brace at the bottom. Strictly speaking, not necessary, but I like to add it for stability. So right now, this is pretty stable. But if I take the brace off, kind of wobbly, right? So that's why I have this. Again, my colleague's design, he's an engineer, so he likes to over-engineer things, and I like to wind him up by saying that he over-engineers things. He had 2 on his. I think 1 is enough. So that's just one of those things. The reason I'm bringing that up is it's just one of those things that you start to learn with materials the more you use them. Like, obviously you have simulation, which is helpful, but the more you actually build physical things, the more you just sort of remember from memory how things behave. Now, if I use like 12 mil thick wood, I know that would be fine. I wouldn't need that base at the bottom, but 3 is kind of flimsy. So I'm going to add that brace. So to add the brace, and by the way, once we added the brace, it's done. Like, yay! To add the brace, I am going to turn on my origin. So in the browser, there's a folder that's called origin, and you just want to turn the light bulb on for that. And that'll bring this up. And then I'm going to use construct an offset plane again. And I'm going to click on this one, which is it's the face that's basically, this is the plane that is facing the front of my laptop stand. So just this one. And then move it forward into the correct position. So I'm just going to move this around and drag that until it is here. So for me, that's 280. But for you, it might be a different distance. You just want it so that orange line is somewhere here. Okay? See that? Yeah? I just move it one more step. There you go. And then just press OK. And then I'm going to make one more drawing for that piece. Ow. And that'll be it. So I'll go to Sketch, create sketch, and then click on that face that I just made. And again, I'm going to use that center rectangle tool just to do this really quickly. So I'm going to go to Sketch and then Line. And I'm going to draw from this corner to this corner here. Yep. And then just press Escape. Now, when I turn it around, you can see that, so from the front, it looks like if I drew that, there would be a collision. But actually, because I'm recessed in, it's just there, and that's fine. All right? So done that, and now I'm just going to go to Sketch, and then Rectangle, and Center Rectangle again, and pick the midpoint of this diagonal line, which is here, and then just do that. Okay. Actually, the bottom here does need to be wider though, right? So to add that, just go to Sketch Dimension, click on that bottom line. Oh, whoops, hang on. No, sorry, that's my mistake. So before I do that, I need to just see this little symbol here that my mouse is on. I need to click on that and delete it. And then do the same for this one at the top. Delete that one. Those were the coincident symbols. So the coincident is a constraint that basically locks a drawing to certain positions. But because I don't want it locked in any position, I want to be able to change the dimensions, I need to get rid of them. The only one that I do want to keep is that one that's right in the center there. Oof, gosh, excuse me. Okay. So now I can add a sketch dimension. So if I go to Sketch and Sketch Dimension and click on the bottom, so it's currently 286. I'm going to make it so it lines up with my top. So I'm going to make that 320. And something has gone wrong. Oh, yeah, I lost my constraint on my... Yeah, you are correct. So I need this to be Okay, let me just check that first. No. What have I done wrong here? Hang on.
You deleted 2 constant constraints.
Yeah.
I think you only needed 1 to be deleted.
I think you are right.
So you just made another.
Dang it! Yep. Oh. What's going on here? Oh, you know what? We'll do it properly. I'm trying to do it the fast way, and it's punishing me. I'm kidding. All right, okay. So, well, there is another way of doing it, which would be just to do it like this. Just to go from here, here, and then down until it lines up like that. So to draw that diagonal, let's do it that way. I don't want to make this as fast as possible. So to do it that way is the same thing. So just delete that diagonal line that you had before, and go to Sketch and then Line, and then pick this corner, which is the bottom left corner of the tabletop. Then draw across to the end, but don't click. Just hover over the end point, and then as you start moving it down, you can see a blue dashed line, right? That's letting you know that it's still like it's diagonal, but it's still in line there. Now, if I hover to this end point and then move across, can you see that they lock where that so it sort of made that rectangle space? So that's called an apparent intersection. So an apparent intersection is, as you might assume, where if there was something, that's kind of where that point would be, right? Does anyone need me to do that again? Yeah? So I'll just do that again. So I draw a line from this end to this end. I start moving it down. That gives me my blue dashed line. Then I move it to here, and I move it across. And can you see it locks where those 2 lines should meet? Yeah? And then just click there, and then the same thing that I did before. So a rectangle with a center point from the middle to here. And now when I turn it across, you can see that's fine. It's not going to collide with anything. Yeah. One more time, or did everyone get that?
Yeah, one more time.
One more time? Okay. So go line. I'll zoom in so you can see it a bit better. So from here, from the base of the drawing. So just click once.
Like, I mean, it snaps there, but it's not.
It's snapping. No, it should snap to the end.
It's not like snap there.
Is it not snapping to it?
I don't know if my plane's in the wrong angle or something. No, I took it just from the back.
I'll come and have a look at yours in a minute.
Yeah.
So for everyone else, just you click once here, move it across to the end point, start moving it down. That gives you that blue dashed line. Then hover over this end until you see the blue square. Start moving it across that way. And then where the corner is basically between the 2. If you lose it, just do it again. Sorry, because I'm trying to do it on that screen rather than checking it on mine. There you go. So that is there. I just click once. That's my diagonal. Then do a rectangle, do the center, pick the middle. That's not the middle. You can draw 2.2 as well, does the same. It's just I like the center, that's all. Again, it's a preferences thing. I mean, it works just as well, yeah. So, yeah. Oh, I see. Yeah, you're right. No, you are right. No, it's just a logic thing. This is how my brain works. It's how I use it. So with that done, just stop the sketch, and then same thing again. We'll go to create and then extrude, and just if you need to pick 2 pieces of your rectangle, just that's how you do it. Just go 1 and 2. And then the distance here again is going to be pi. And again, it's going to try and cut the whole thing, right? So just set that to new body, press OK. So this time, we're going to do the same thing. We're going to start with the same thing and go modify, combine. And I'm going to use cut. And I'm going to cut these 2 with this. But I only have to select the one and then this one. And now when I press OK, with keep tools on, so the order there, by the way, so the target is the leg, and the tool is the brace. And now here operation says cut, keep tools, OK. But if I open up my browser and hide this that I just made, you'll see that it did it on the other side too. And that's because I used a copy paste earlier on. So whatever I do to the original one is going to get done to this one too, because they're linked, right? It's pretty handy. So,
Can you also unlink?
oh, the unlink the page, not with the copy paste. There's just a different way of making it. So, if you use copy paste, they're always linked. But there's a tool that is called under create that's called pattern, and if you do it with a pattern, they will be independent of each other. Okay, so once you've done that, you want to do exactly what I did. So just open up here where it says bodies, and then just turn off the light bulb for body 3 or whatever it is that piece is called. And basically, just move this down a bit. So to move that down, essentially what I'm doing is I'm creating this joint, right? A tooth and comb joint, not a tooth and tooth and comb? Mortise and tenon? Slot joint. So it's a slot joint. So basically I'm creating that slot joint, but it's really like the old school way of doing it would have been in that rectangle to also draw the holes and push it, blah, 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 blah. Too much work. So to do it in Fusion, all I'm going to do is draw that as I did. I've got too much of a slot here. Under Modify, there is a tool that is called Press Pull. With Press Pull, I can pick that face and just start pulling it down. Right? So I'm just going to pull it to here, 15, and then press OK. And if I zoom, you can see it's done the same on the other side. All right? Turn on body 3 again, and this time go to Modify, Combine, using a cut again. This is the target, and the tools are this and this. I press OK, and now if I hide the legs, you'll see that it's made the corresponding cut there. Super easy. Does anyone? I did that really fast. Do you want to show it to you properly? So good, right? So to do this, we're just going to go to Modify, Press Pull, and then pick that face. Did everyone do this bit? You might want to start doing it too. Just by the way, a handy thing with the Press Pull, this arrow, let's say for example I wanted to fill it to this edge. So I can either just pull it, but it will keep going, right? And I'll try and line it up by eye, but that's really difficult. So if I did it till here, and because I've been pulling on this, if I highlight that face, it's going to line up with it. That's just super useful. So I'm just going to move that back. So basically, I'm going to drop it. Yeah, let's say 15. 15 is good. Then click OK. You can see that it's pasted it on the other side. And now just turn on body 3, turn that back on. And now we'll go to Modify, Combine, Cut. Keep Tools is on. So the target is this. And the tool bodies are this and this. Press OK. All right. That's it. Congratulations, you just made a laptop stand. There are extra steps, but that is what I call bonus content. So on my YouTube channel, so if you want to find my YouTube channel, that's Hughes PS Says on YouTube. It's not up yet, but there will be a tutorial on this one. And it has all these extra bits. So the weight saving that is happening here. The filleting on the corners, although this is very easy to do, there's just a tool that's called fillet and you pick the edges. One of the extra things that I did with this one, just to make it a bit easier when I'm slotting it in, is the corners here are rounded, right? Just so that when I press it in, it presses in nicer. Well, I might as well show you how to do that. It takes like a minute. So to round the corners, all you got to do is we'll just up once to that last piece, and then you guys can do it to the others in your own time. So what I'm going to do is first I'm going to right click. Sorry, my mistake. What I'm going to do is I'm going to turn the light bulbs off for leg 1, leg 2, and component 2, so that I'm just have this piece. All right, and then under modify, there is a tool that's called fillet. And I'm going to pick this one, this one, this one, and this one. And I'm going to add a fillet that is ply divided by 2. All right? It's just a good rule of thumb for laser cut stuff. And then press OK. So now, if I ever change that, these radiuses change correspondingly. Because if I use a fixed number, it's going to make life difficult down the line. And I basically just went around and did that to all the other bits. And that's how you do it. So just to show you some of the timeline stuff that I was talking about, all these extra holes on this version, they were made by double-clicking on this first drawing. So returning to this first drawing, and I'll just show you just like a simple one. If I go to Sketch and then Circle, and I draw a circle like this here, and stop the sketch, and then go back to the extrusion that I did, and here where the profile is, if I press Control or Command if you're on a Mac, and deselect that one, and press OK, it just updates everything, right? It just, every step that is related, so all these, down here in the timeline, all these extra steps that pass on afterwards are just updated correspondingly. If you do anything that breaks the model, because it is possible to do something that's absolutely crazy that works at one step but not on all the other ones, Fusion is going to tell you. So it's going to highlight down here some of them in yellow and some of them in red to say that these don't work and you need to fix them. One of the other things is obviously the wood thickness that we did. So here where it says 6, if I change that to 12, it updates. One of the things that obviously has happened here is that this wood thickness is now thicker than the tab that I made, and it's pointing that out to me. And if I go back the other way, if I change it to 3, again, the tab, because I didn't put a dimension on it, I need to just update that. Actually, I don't know why the tops didn't work. There's something wrong there. That's interesting. What happened here? Oh, they disappeared. Okay, let me figure that out. that's fine. I tell you what, it's 3:20. I'm sure people want their lunch. I will put it on the YouTube channel when I make that video to make sure that everything works properly. Okay, just save your file, and that's it. So if you're ever looking for more content or you're interested in tutorials, I go to YouTube. So we have the Fusion 360 channel, which you can just find by searching for Fusion 360. And if you go to the channel and go to playlists, you can see well, different playlists for different things. There's a Fusion 360 for beginners, which is 7 videos that just runs through the most kind of rudimentary steps. There's tutorials for specific areas of Fusion. If you're looking through the main videos, you'll see here there are quick tips and the tutorials. The tutorials are made by my team, so like here's one that I made. They're a little bit more in depth, and obviously they're YouTube, so you can pause them, which is handy. There's lots of different things. It goes everything from basics through to really advanced stuff, and then some of the slightly more fun ones, like 10 ways to make a box. I'm not even kidding. There's genuinely 10 different ways to make a box. And then there's my channel, which currently is a little bit empty, but I'm filling it up. Is this one? See my super happy smiley face? There I am. So there's only 2 videos on here right now, but this one is basically Fusion for absolute beginners. And I spend a lot of time just explaining the user interface and how the tools work. And at the end of it, you'll have something like this. All right? And this is totally 3D printable. It's actually also designed to work with IKEA furniture. So if you go to IKEA and you buy an IKEA pendant and light bulb, you can actually make the lampshade. So there's a functioning lampshade. I have like 3 of these in my house. Cool. Okay. That's it. Thank you very much. I hope that was helpful.